All right, welcome back, folks. This time around, we are diving into next set of questions which involve the programming concepts we're talking about. The next problem we want to look at is the definition of abstraction. And we said when we are abstracting, we are hiding. So this is removing unnecessary detail from a problem to focus on essential features. So it's removing unnecessary detail from a problem and focus on the essentials. So it has got its benefits because if you are, trimming or cutting down to the most important part, then it means there is benefits you are bringing into the programming sphere. Say two reasons why abstraction is important in computing. I've spoken about one. I mean, it reduces complexity. That's one. It reduces complexity. And the moment the uh, production is not complex, it's going to be easier to design and understand. So it becomes easier to design and understand. The next problem, we are interested in identifying two features removed when modeling the real-world game. So real-world game, I mean, it involves other features like the temperature system, the engine components. So things that we might remove there can be individual engine components, individual engine components, as well as the real-world physics are some of the things that can be removed to make modeling a bit handy. Now, next we want to define decomposition. Well, with decomposition, it's just breaking down a large problem into sub-components which are easier to handle or manage. So this is breaking, it's a process of breaking down a large complex problem into smaller manageable subunits. So that's decomposition. Decomposition, can we decompose a calculator program into four subtasks? Or so with a calculator, what are we interested in? I mean, with a calculator, you might be interested in inputting numbers, or you input numbers. After you input numbers, you can make a selection of picking or an operator. So you can select operator there, select operator. So operators can be add, subtract, multiplication, you name them, all those that perform arithmetic operations. Then what's next is processing of the input information, which we can say you perform calculation. Once calculation is done, obviously you will need to display the results on the screen. So we can now display the result. Right, then next problem, we want to state two problems caused by poor identifier names. Now, with poor identifier names, it makes the whole entire process difficult to follow. So it makes it difficult to follow the code, especially when it comes to debugging and stuff. You want to identify where the mistake is. If it's made up of meaningless identifiers, then it becomes very, very challenging to follow or to understand. And one other challenge is the maintenance becomes a challenge. It becomes hard to maintain. You want to perform changes or updates to the system, but now if you can't make sense of the variables or identifiers, then everything becomes hectic. Suggest three good identifier names for a banking system. So now within a banking system, one might own a bank account. So you might need an account number, and within your account, you might need to know how much money you have. So we can talk of account number. We can have another variable, account balance, that's within the banking system. Then we might also look at the name of the account holder. So we can call that customer name. I think these are variables which are followable if you are coding to do with a known system to say this is a bank system. Now we want to write a pseudocode to input two numbers and output their sum. So if we are inputting, obviously we use the keyword input. Let me call this num1 to say it's number one, and input num 2. Then what do I do with this? I'm now going to declare a variable sum, which we are saying it becomes num1 plus num2. Then what do we do then? Output sum. I think basically that's what we have from that particular pseudocode. Then the next problem, number 9, we are interested in identifying the selection statement. And when we say selection statement, here we are interested in a pseudocode which says if age is greater than or equal to 18, then output adult. Then we end if. So we want to identify the selection statement. So the selection statement here is going to be the conditional, say if, then, that's the selection, because this will only happen if a certain condition is met. Explain what stepwise refinement means. When we talk of stepwise refinement, we are looking at a general solution which is gradually broken down. So this is breaking down a general solution. We are trying to confine it so that it becomes as accurate as is possible. So into more detailed steps. So bring a general solution into more detailed steps. I think that's it, folks, on part 2. Let's meet again on the last part where we are discussing 10 similar problems to the ones given. Bye for now.